We are here in Helsinki with Sabrina Maniscalco, and we are talking about Quantum Game Jam. So, Sabrina, tell us why Quantum Game Jam? Why Game Jam for quantum physics?
Well, I think that there are many reasons, but nowadays it's becoming very important to try to find new ways to tackle research in quantum physics involving people. And one of the ways is using games, and we have already had this experience a couple of years with Anna-Kaisa and the Finnish Game Jam Association, and we believe that it's a great opportunity to do things in new ways of stimulating creativity and involving people in research.
Why do we need to have the creativity of the others? Isn't it enough that the scientists are creative enough?
Well, I would say two main things. The first one is that we do struggle a lot with understanding quantum physics because it is so counterintuitive. So we always think in terms of experiences that we do in our daily life, and this is not how quantum particles work. So in some sense, this is something that requires to be even more open-minded than normal. It's a very famous quote by Richard Feynman, who said that if a scientist says that he understood quantum physics, it means he didn't understand anything at all. So actually, it is really difficult to struggle. Of course, we may develop, and we do develop, a familiarity with certain concepts, but familiarity is different from deep understanding. They are a fantastic tool to be completely free to create, and we think that this is really what we need for research in quantum physics.
In Quantum Game Jam, we're actually using a black box thing that you've created. Can you tell us a little bit about what is this black box?
Yes, and this year we will have even further developed black box with even more power. So the black box is something which contains inside a simulation of a real physical problem. Using the black box, which of course participants do not need to know in detail the dynamics of the physical problem, but using the black box to create the games, the players, while playing, are helping to solve an open research problem in quantum physics.
So it is about crowdsourcing of the results or kind of the problem.
Yeah, exactly. All these type of problems are problems related to quantum computers and quantum technologies that nowadays are being developed and in some cases already commercialized. So basically, in this way, everyone can help building a new quantum computer.
But if you don't want to create a game for the black box that you created, can you also create something just thematically for quantum?
Yes, of course. We always have also a theme to develop some games that help in some way educating in quantum physics, or try to, in a way or another, teach people some intuition about quantum physics, because quantum physics is very counterintuitive, and nowadays it is clear that it will be at the basis of a lot of new technologies. So in the sense of scientific literacy, it would be very nice if you would have at least some understanding of how these things work, because they will be the basis of our future technologies.
Which quantum physics topics have we actually already explored?
Yes, we did work on something called quantum entanglement, that is a very special correlation that only quantum particles have, and this special quantum correlation is such that the two particles are actually behaving as one. Even if they are very far apart, they can be in two completely different parts of the universe. And then we also had some game based on quantum computers, and in particularly a specific class of problems based on search. So this was mostly a searching algorithm that we explored. Is the basically the most important algorithm that is known to work well on a quantum device is called the Shor factoring algorithm.
Is that something that is used in encryption or
Yes,
something
exactly. This is one of the reasons why people are so interested in quantum computers, is exactly that quantum computers could break any cryptographic code currently used. So they would be a threat in a sense for society.
So we need to be kind of aware of that
Yes,
as well.
of course, yeah.
What do you think about the relationship between sci-fi, the narratives that we see in the movies or games, and then actual science?
Well, of course, there is more and more interest from sci-fi authors and movies into quantum physics, and there is a lot of inspiration in many of the main features of quantum physics. If I think about, for example, the whole concept of parallel universes and the fact that observation changes quantum systems differently from classical cases, so there is always an influence whenever we measure or observe something. So there are a lot of elements, I think, currently used in science fiction and also in movies and in games.
Yeah, so it's not all about just the stories. It's actually based on some of the concept that we already know in the science.
Yes.
So in some ways, it's already teaching us to understand these concepts when we just engage into the entertainment.
Yes, that's for sure. I mean, it's one of the, I think, most fascinating aspects. And this is something that we as scientists still need to learn a lot. So quantum game jams are something very exciting for us too.
Now, for the participants of the quantum game jam, what is the reason to actually get involved into this movement of quantum and games? What would be your reason?
Well, of course, it's fun. And obviously, there is another aspect, that is the fact that you will be fully engaged in something that is very useful for research. Scientific literacy is something that is particularly important nowadays in our society. And also, I think that it would be very fascinating to enter into this mysterious world of quantum physics and learn some of the most amazing aspects of nature.
Thank you, Sabrina, for enlightening us with quantum physics and the relationship between the games that we're going to create and then the actual science. And hopefully we'll see a lot of jammers to join our event to explore this topic and to be part of the movement, I would so call.
Yes. Thank you.
So, thank you.
Bye.